Question 18 says an artificial satellite is moving with constant speed √2 into 10 to the power 4 meter per second in a circular orbit about the Earth. An object of mass m equal to 3 kg is ejected from the satellite such that it just escapes from the gravitational pull of the Earth. If at the time of its ejection, the kinetic energy of the object is n into 10 to the power 8 joule, then the value of n is. Okay, so this artificial satellite is moving in circular orbit around Earth, and in that case we know that the potential energy is minus 2k, and the total mechanical energy, this is for the satellite, and the total mechanical energy is minus k as far as the satellite is concerned, right? Let's say it's minus k. Okay, this is the value of u. Now for the object of mass m, the value of u will be, let's call it u dash. That means the gravitational potential energy of the particle of mass m when it's moving with the satellite, and that is equal to minus 2 times half mass of this particle into √2 into 10 to the power 4 square. That is the gravitational potential energy of the particle when it's moving with the satellite, right? And we should give it kinetic energy so that its total mechanical energy becomes 0. That is what it means, that it has to escape the gravitational pull of the Earth. So that means u dash plus k dash has to become 0, or k dash then is simply minus u dash, and that means it is equal to m into 2 into 10 to the power 8 SI units. The value of m is 3, so that means it is 6 into 10 to the power 8 joule. So that means the value of n is 6, and as per the format of the question, it should be 06. Let's now go to the next question. Question 19 says, consider a spring block arrangement over smooth plank as shown. At t equal to 0, the plank is made to accelerate with acceleration a. Maximum compression in the spring in SI units will be, and given ma by k equals 4 SI units. Okay, we can apply the work energy theorem, and of course we also consider the work done by the pseudo force. So that means we are observing from the reference frame attached to the plank. So at maximum compression, the speed of the block with respect to the plank is 0. So we have change in kinetic energy which is 0. 0 is a change in kinetic energy, and this is equal to work done by the spring force plus work done by the pseudo force. Work done by the spring force is minus half k xm square, and work done by the pseudo force will be ma xm, where xm is the maximum compression. Now this simply tells us that the value of xm is 2 ma by k. Ma by k value is given to us, so that means this is 4 units, so this is total 8 SI units. So the answer to question 19 is simply 08. Pretty simple, isn't it? Let's go to the last question now. Question 20 says, a uniform semicircular ring MR is hinged at its one end in vertical XY plane. If angular acceleration of ring just after release from this position is alpha equal to ng by pi r, then value of n is. Okay. So the mass of the semicircular ring is m and r is the radius. We know that the moment of inertia about this axis will be, well, to find that we can put another half ring like this just to make it easier, and 2 times I, because we are considering 2 times the system, right? We have put one more half ring here. So if moment of inertia of one semicircular ring is I about the hinge, that means about the axis to the hinge, then we have 2I is equal to the value about this would have been 2mr square plus 2mr square, that means 4mr square. So that means I itself for one semicircular ring, it is simply 2 mr square. So one part is done. Now if the system is released from this position, let's concentrate only on the one semicircular ring now. So we know the center of mass is somewhere here. This distance is 2r by pi and mass is m, so force is mg. The torque about the hinge will be then mg into 2r by pi, and this is equal to I alpha. That means it is equal to 2 mr square into alpha. The value of alpha turns out to be equal to g by pi r, and that means the value of n is coming out to be 1. Yeah, as per the format of the test, we have to put it as 0, 1. So the answer to question 20 is 0, 1. Well students, with that we come to the end of this quick solution. Hope you found the solutions useful. I wish you all the very best. Take care. Bye.